Hello, pre-calculus students. I'm here with the end of the notes from Lesson 3 in Unit 2. And we were talking about concavity today in class, and I was not able to finish it. What we had done was we had colored the concave up green and the concave down we colored blue, so it should have looked something like that. And then I wanted to put a point where it changed, a point like about right there. That point is called the point of inflection. So what we had said was a function is concave up when it looks like a smiley face. It's concave down, kind of looks like a sad face. And what we didn't get to is a function f has a point of inflection. That's an I. A point of inflection at C on an open interval if the graph changes concavity. So about right there is your point of inflection, okay? And so, and the biggest thing you need to remember on those, and I'm going to highlight it, is point of inflection at C on an open interval I if the graph changes concavity. So right where it goes from being concave up to concave down. The tangent line will be above the curve on one side of C and below the curve on the other side of C. And it says draw an estimate for this point in red, and I did it in pink, but you can see that like earlier today, let me use a different color here. I was telling you that if you were talking about the, thinking about tangent lines, see how these are all on the underneath. When it's concave up, your tangent lines are underneath. But then you get to a point where it kind of could be either one here, but you really wouldn't put it under right there. So, you wouldn't do that I just did. Oh, shoot. Let me put that back on there, sorry. Put that back on there. But what we would do instead is see how our tangent lines, once we get to that where it's concave down, they're going to start being above, the tangent lines are going to be above the function. See how they are above it and not below it. So that's kind of another neat thing. Now, what I'm going to add here that I'd like you to add to your notes is finding points of inflection. Right now, we can't use calculus because we're in pre-calculus. So we still want to know the terminology. We want to know what it looks like, what we're talking about. But if we were going to look for a point of inflection, one thing we could look at is it could be a 0 with multiplicity of 3. That would be somewhere. So if we looked at the function y equals x cubed, we can see that right here is a 0, and it has a multiplicity of 3, and so it kind of flattens out. It's hard for me to draw, but it does flatten out there just for a brief moment. But look at the concavity. notice that you have, well, I'll just grab the blue one. You have concave down here, and then I'll grab the green one. You have concave up here. So do you see how that 0 is where it changes concavity for a third degree function? So that is interesting. Number 2, you could estimate a possible point of inflection and this is just going to be an estimate between 2 consecutive maxes or mins. Okay, so do you see how these are consecutive? There's a min and then there's a max in this graph above. So they are consecutive. So what we could do, if we knew exactly what these points were, right? If we had our function, put it in our calculator, we calculated the max, calculated the min, we could figure out halfway. What is halfway between these two x values? That would give you the x of your point of inflection, and also halfway between the two y values. That would give you the y of your point of inflection. Okay, so let's say that this one is x1, y1, and that this one is x2, y2. Our point of inflection would have an x value of your x1 plus x2 divided by 2, and it would have a y value of y1 plus y2 divided by 2. Okay, so it's like halfway. So those are the notes that I added on points of inflection. And they actually skipped this example in your notes, but I'm going to go ahead and do it because I don't want you to skip it, okay? And so they've given us this graph, and they're asking us questions. Intervals of increase, okay? So think about it. You know, this is decreasing here. Actually, I'm going to get my yellow one, and I can always erase it. We've got decreasing here, we've got constant, we've got decreasing here, and we've got decreasing here. So I'm going to say yellow is decreasing. I'm going to say pink is increasing. There's increasing. There's increasing. Okay, so pink is increasing, because see how the function is going up. And then let's say blue is constant. So we've got constant right there. So we're going to say that blue is constant. Okay, so now let's try intervals of increase. Well, it's going to be from D to E. And I'm going to use interval notation. So that means from D to E, and also from F to G. Intervals of decrease, okay? Those are from A to B, because it's decreasing from A to B. It's also decreasing from E to F. And it's decreasing from G to H. Now, since this actually goes like that, over here it's a solid dot and it stops, you know, at A. But it gives you that, I'm going to go ahead and say G to infinity. because up at the top here, it never did say, oh, you only need to go from A to H. If it had said stop at H, I would have put G to H. But I'm going to go ahead and assume, since it goes down like that we're going to infinity. I'm going to put G to infinity. Intervals of constancy, that one, B to D. Mark and estimate 2 points of inflection, K and M. Well, you've got concave down here. I'm gonna get another color going on here. Got so many colors. Why not? So I have concave down until about halfway. Okay? Oh my gosh. Can't write with that one. Concave down until about halfway. Let's say about right there. Then we've got concave up. I'm going to have to find one that's smaller. Put it on that and do pink. Okay, so now we've got concave up. You see concave up there? Smiley. Smiley, concave up. Okay, I'm going to have to stop the video. I'll come back.